Chapter 12 is going to focus on a whole bunch of new reactions for us to learn with oxidations and reductions of organic compounds. So to start with, we need to talk about what oxidation and reduction are. So oxidation is not actually an increase of oxygens in the molecule, and it's going to be a little bit different than how you learned it in general chemistry, where it was about losing electrons and gaining electrons. So oxidation in organic molecules is an increase in the number of C to Z bonds, where Z is something other than hydrogen, or you can also think of it as a decrease in the number of CH bonds. So for example, if we were to go from an alkane to a ketone, there isn't really a reaction that you can do that, but this change would be an oxidation because I increased the number of C to Z bonds and I decreased the number of carbon-hydrogen bonds. Now, one of the reasons that this is valuable to have both different definitions is that now if I look at this one, I actually don't have any CZ bonds. So Z is usually something that's non-carbon, non-hydrogen. However, I have decreased the number of CH bonds by 2. So this is also an oxidation. So hopefully if I ask you then what is reduction, you'll be able to answer that. It's an increase in the number of CH bonds or a decrease in the number of CZ bonds. So for example, if I have a ketone and I convert that into an alcohol, there's a new CH bond here, so I've increased the number of CH bonds, so this is a reduction. Also here I have 2 CZ bonds, 1 sigma bond, 1 pi bond, and here I only have 1 CZ bond. And by the same token, if I have an alkene, I can convert that to an alkane, that's also a reduction, because I've added 2 new carbon-hydrogen bonds. So it's an increase in the number of CH bonds. If you want to think about it this way, the most reduced you can ever get in carbon would be CH4, and the most oxidized you're ever going to get with carbon would be something like CO2 with 4 CZ bonds.